Hello guys and welcome to Mossy Maths with me, Tom Moss, and today we're going through the first lesson on a new topic called simultaneous equations. We're going to be looking through the very basics of this topic. This is the final topic of Core 1 AS Maths. After we finish this, we'll be moving on to Core 2, which is the second unit of AS Maths. And in this lesson I'll be going through a real life example that I've found and also an example from the AQA revision guide, the latest version, okay? And for those of you that have seen this at GCSE, it might be worth skipping over to my next video, which is on how we solve simultaneous equations when one is a quadratic. And that's slightly more difficult. But for now, let's go through how we solve a basic simultaneous equations question. And the steps are here. The first one is we match the coefficients of a variable. Now, by a variable, I mean x or y or z or whatever the letter is. That's a variable. And the coefficient is the number in front of that variable. So take this example, minus 2x, the coefficient of x is minus 2, the number in front of it. The coefficient of y here is 3. So that's all I mean by that. The second step is to eliminate to find one variable. And the way we eliminate is we get one variable in both equations having the same coefficient, and we can cancel them out. And again, I'll show you what I mean with these two examples. The third thing we do is find the other variable, which is the one you've eliminated, by substituting the one you found back into either of the equations. And fourth, check your answer, which we do by substituting into both equations. So, I found a real life example here, and I just want to show you that simultaneous equations do apply to real life situations, and unlike many topics in maths where you might think, how is that really going to help me in real life? Well, this is an application of simultaneous equations. Say we've got a distance in metres and time in seconds of two sprinters, okay? This is person 1, this line here, and this line represents person 2. So one person starts at the origin, okay, when the time is 0. Someone starts straight away and runs. But person 2 is faster than person 1, and they start maybe after 5 seconds. So how long would it take for them to catch the other person up if they're faster? Well, if we knew the equations of both lines, okay, then we could use simultaneous equations to solve this, to find the point of intersection, because that's what we can use simultaneous equations for, to find the point of intersection of a graph. And that would therefore give us the time and distance where he would catch the other sprinter up. But we need the equations of both. We need that to find the point of intersection, okay? So that's an application in real life. If we knew the speeds of the runners, then we could find the point of intersection, which is where they would catch up. So we're also going to go through this example here, which says if A is the price of an apple and B the price of a banana, and 2A plus 3B equals £1.80 and 4A plus 5B equals 3.2 or £3.20. Find A and find B. So, if A is the price of an apple, okay, so we'll write these equations out. 2A plus 3B equals £1.80, okay, 1.8. And we've got 4A plus 5B equals £3.20. And we need to find A and B. So the way we do this is we solve simultaneously. We have to get one variable having the same coefficient. So how can we make either the A's or the B's the same in both? Well, I can see straight away, if we multiply the top equation by 2, multiply the whole thing by 2, then this 2A will become 4A, and then we have 4A in both, so we can eliminate them. So what we do is we multiply this top equation by 2. However, when we do this, we have to remember to multiply every variable by 2. The 3b, the 2a and the 1.8. So let's multiply it by 2. The top equation becomes 4a, multiplying it by 2, plus, well, 3b times 2 is 6b, equals 1.8 times 2, which gives us 3.6. And the bottom one can stay the same. We'll leave that as it is, because now we have the a's with the same coefficient. Okay? So, how do we eliminate one variable, which is the second step? Well, we can simply subtract one from the other. We can see that if we subtract 4a from 4a, we're going to get 0. So if we subtract this equation from this, the a's will cancel, and we'll get 6 minus 5, which is 1b, so just b, equals 3.6 minus 3.2, which is 0.4. So b is equal to 0.40, which is 40 pence in the context of the question. So a banana costs 40 pence. So now how do we find out the price of an apple? Well, we have to substitute this value of b into either of the equations, and it will give us the same value. So we can use either of them. And this is step 3, finding the other variable, the one that we eliminated, which was, in this case, the price of an apple, a. So we substitute b as 0.4 into either of these. I'll pick the top one. So we get 2a plus, now 3b, that means 3 times whatever b is. We found b is 0.4. 3 times 0.4 would be that part, equals 1.80, £1.80. So if we simplify this, we get 2a plus 3 times 0.4, that's 1.2, equals 1.8. Now if we subtract the 1.2 from the 1.8, moving that across, we get 2a equals 0.6. And therefore, dividing both by 2, we get a equals 0.30. So the price of an apple is 30 pence. So we found a and we found b. So we've solved the question. We found the value of an apple and a banana. We find the price of both. However, we now need to check, because although this will fit in with the first equation, we need to check it also fits in with the second. If it does, we know we've done it right, but if this doesn't work out, we know we've made a mistake somewhere. So we can sort of do this in our heads if we like. 4 times the price of a. Well, if a is 0.3, 4 times 0.3 is 1.2. 1.2 plus 5 times 0.4, so that's 1.2 add 2. Well, that's 3.2. 1.2 plus 2 is 3.2. So that works. And we know it works with a because that's how we found our value of a. So a is 0.3 and b is 0.4. So we could state that. Again, you might need to relate this in the context of the question, depending on how it's worded in the exam. So that's the answer to the first question. Now let's move on to the second one. Solve or find the point of intersection of 3x plus 5y equals minus 4 and minus 2x plus 3y equals 9. Now, the reason I've written solve or find the point of intersection is because they mean the same thing. If we're solving these equations, what we will find is a value of x and a value of y, which on a graph is a point of intersection. It's the coordinate where the two lines intersect, okay? So I'll draw that out when we find the answers. So if we solve these, we need to write them one above the other in this way. We write it like this because that way we can see how we get one variable the same in both. So we could multiply the top one by 3 and this one by 5 to get the y's the same. However, we could multiply the top one by 2 and the bottom one by 3 and we'd get the x's the same. So if we multiply the top one by 2, we get 6x plus 10y equals, well, minus 4 times 2 is minus 8. Be careful with the negative there. With this one, if we multiply this by 3, we then get the coefficient of x to be the same. Minus 2 times 3 is minus 6x. 3y multiplied by 3 is 9y. And 9 times 3 is 27. Now, we don't need to worry about the fact that the 6x and the minus 6x have a negative and a positive coefficient. All that matters is that they're the same number. Okay? It doesn't matter if one's negative and one's positive, as long as we've got the same number in front of them, because, like here we subtracted because we had the same sign. They were both positives, positive 4a and positive 4a. So we subtracted one from the other to get 0. However, here, because we've got a positive and a negative, we can actually add these together. 6x plus minus 6x is 0x. Okay? So if we subtracted them, if we did 6 minus minus 6, we'd get 12. That wouldn't eliminate. So we have to add them in this case. If we add minus 6 to 6, we get 0. So they will cancel if we add them together. If we add 10y and 9y, we'll get 19y. And if we add 27 and minus 8, remember, positive 27 add a minus 8 is going to give us positive 19. Okay? And now we just need to divide both sides by 19 to get y equals. Well, 19 divided by 19 is 1. So y is 1. And similarly to the previous question, we now need to follow step 3. Substitute our value of y into either of these equations. Again, I'll use the top one. 3x plus 5 times y, well 5 times 1 is just 5, equals minus 4. So let's move the positive 5 across. And doing that, we get 3x equals minus 4. This is going to become minus 5. Minus 4 minus 5 is minus 9. So if 3x is minus 9, then dividing both sides by 3, we get x equals minus 9 divided by 3, which is minus 3. So we have a value of x that is minus 3 and a value of y that is 1. And to check that, we could now substitute it into this second equation. Minus 2 times x, well minus 2 times minus 3 is positive 6. Plus 3 times 1 is 6 plus 3, which is indeed 9. So that works out. And the first one we know works because that's how we found the value of x. So we've now proved that x is minus 3 and y is 1. Okay? So what if the question asked us to find the point of intersection? Then all we'd have to do is write this as minus 3, comma 1 as a coordinate. That's the point of intersection. Okay, so that's where the two graphs would meet. So there we go, that's simultaneous equations, that's the basics of it. In the next lesson we'll be looking at how we can solve simultaneous equations when one is a quadratic by substitution. So thanks a lot. If you do have any questions, leave a comment. If you found the video helpful, please leave a like. And I'll see you in lesson 2 on simultaneous equations.